In the diagram below, AD intersects BE at C, and AB is parallel to DE. If CD is 6.6 centimeters, so CD is 6.6, DE is 3.4, CE is 4.2, and BC is 5.25. BC is 5.25. What is length AC to the nearest hundredth of a centimeter? So they want us to round to 2 decimal places. There's one more thing I forgot to label, and that is AB is parallel to DE. So these two line segments are parallel. Okay, so why is that important? Well, it's important because knowing that these two lines are parallel, it'll then allow us to identify angles that are going to be congruent. Angle B is going to be congruent to angle E. And the reason for that is because of alternate interior angles. We have a pair of parallel lines cut by a transversal. And then over here, we have a pair of vertical angles. Those two angles are also going to be congruent. And so therefore we can then justify that triangle ABC will be similar to triangle DEC. So with that in mind now, okay, the goal is to find out what is the length of AC, which I'm going to call X. So then I can see here that AC will correspond with DC, right? So then I can form ratios because of the fact that these two triangles are similar. And again, they're similar because of the angle-angle theorem. I forgot to state that earlier. Okay, so I can make comparisons now. I can set up proportions. AC, which is X, is to DC, which is 6.6. Now, this proportion will hold no matter which other side I pair this up with. So I can then say 5.25, that's BC here, is to EC, which is to 4.2. So I can say 5.25 is to 4.2. So with that, I can then solve for X. And again, X is AC, right? All right, so what I'm going to do is I'm going to multiply both sides by 6.6. And if I do, I'll end up with X is equal to 5.25 times 6.6 divided by 4.2. So I'm going to take my calculator, 5.25 times 6.6 divided by 4.2. And that's 8.25. So X is equal to 8.25. And that would be option 4.